Såg han att Andreas skrev? Ja, precis.
That is the best to sleep in the morning, yeah, and you're able to make it. Yeah. But you have to experience this in order to really enjoy it. Good. Ser du skärmen eller sitter så på sidan? Det blir liksom... Jag ser skärmen. Vad menar du? Nej, men ibland så är det ja, men jag ska sitta där framme.
Så är det David där och så är det David som är där.
Ja, det var någon som skulle visa något på lunch.
Okej, men vad var Andreas som skrev? Johan, frågan om de har koll på ljudet.
Ja. T-5 seconds.
Good morning, everybody. Good morning. Welcome to the Challenge Lab and the final presentations of this year's master thesis. My name is David Andersson, and I work here at the Challenge Lab with the team, Johan and John, founder of Challenge Lab. And we are really excited today. It has been a long journey for the students, and they will present it now for 2 days, today and tomorrow. And I guess you all have had fika, but there will be a little fika break later. But first of all, we will have an introduction of the Challenge Lab, and after that, Joel and Patrick will come on stage, and I will introduce them later. And if you have any practical questions, just let me know. I'm here for you today. But for your convenience, there are toilets in this corridor, and also bonus bathrooms on the other corridor also. Some water over there by the tap. If you want to complement the coffee with that, please grab some as well if the water is out. Yes, so with that, I would like to introduce John, founder of Challenge Lab.
Thank you. Thank you. And very welcome. Maybe we should also mention that Andreas should be here, but he's unfortunately on Hawaii. Also in the team, and Örjan is not here. And Christine as well. So we are some more. And then we have all the supervisors for a team. So they are also involved in the challenge lab. So we are quite a few around the students. What I will do now, just for a couple of, for about 12 minutes, is to give you some understanding what are we actually doing here and why do we have a challenge lab. And then it will be all up to the students. So one starting point is the big UN processes. And from the big processes that you have heard about with the 17 Sustainable Development Goals and the climate journey that we have globally, we can actually extract three main keywords. And one is universality, that it's not enough to solve it in US, it has to be solved everywhere. And the same is for every country. And then we have transformation. And that means that business as usual is not okay anymore. We have to really look at system and change system on a system level, transportation system or energy system. And it has to be transformed into something different, not adjusted, but transformed. So transformation is the second one. And then we have a third one, and that is integration. And that means that we cannot first work with climate and then social aspect and then other aspects. We have to, when we do things like change the transport system, we have to look at it from a climate perspective and social perspective simultaneously. And that also means that we have to integrate our stakeholders in that work, co-create the solutions. It's not okay. And it's not possible even for one stakeholder to do it alone. So those are the three keywords that are behind, you can say, the Challenge Lab idea. It's not just to invent things. You have to really address universality, transformation, and integration. And that is behind what we're doing. And in this region we have tried, because it will happen in cities and regions. On national level, it is very much silos still. But on the local level, you face the reality, and in the reality, you see all the different perspectives and the complexity. So we really think that here we will create the examples showing and can be spread to other cities and compared and related to each other. And we have started this journey in this city. And we really think that students can be an important part in the center, in between society, industry, and academy, to integrate the different stakeholders. They have a special role to play in that. Students do not represent anyone. Everyone knows what it is to be a student. And students are very eager to change, but still do not threaten anyone. So maybe students can integrate stakeholders in a better way than other stakeholders can do. Maybe it is. That is what we are trying to test at Challenge Lab. And we see some good results from that. Because still society looks like this, very much in silos. And we also, when we face a problem, we often see it like this. We see some symptom of the problem, like the increased cost and decreased resources. What do we do to deal with that? Often very, pull a wheel or a steer wheel to reduce the cost, and often then that means that everything that is in between people and in between stakeholders are not efficient to work with. You should focus. But what that means that we decrease our listening and observing. That means that we misunderstand each other within organization and between organization, and there will be a lack of trust. And that means social separation. The same thing is done in different places: redundancy, internal competition, and fear and separation. That is what we see everywhere. And that drive increased cost and decreased resources. And then we wonder, when we did that, why does the cost increase even more? Because we don't see what's happened below, because we cannot measure this. So what we'll try to do is to more listen, observe, bring stakeholders together, understand each other, create trust for co-creation, collaboration, for increased creativity and further collaboration. So that is one thing that we're trying to achieve. Another is
master programs and their expertise in their teams. And the one we're going to listen to now, Patrick and Joel, have two very different master program backgrounds. And even more exciting is that their master thesis is also about disruptive technology entering an old industry and the integration of that. So it's going to be really interesting to hear your presentation now. So welcome on stage, Joel and Patrick. Meanwhile, I can also mention that these presentations are live on YouTube on our Challenge Lab YouTube channel. So you can get if you want to rewind later and look at the best parts, something you missed and something you maybe didn't ask a question for, then you can look at that afterwards. And we have Erik from this fine group called Blended Learning that provides us with the live stream. Okay.
Right. Hi everyone. I am Joel, and this is Patrick. And we've been exploring the intersection between mobility as a service and blockchain technology. And Patrick is going to take us right out.
Right. So this is the challenge we face. We all know these pictures. Pollution and congestion. And what we all can agree to is the fact that the current transport system is in a need of transformation, just as John told us, because it has a wide range of problems. We now face challenges related to negative impacts on our environment. With pollution and greenhouse gas emissions, we also have inefficient use of resources, and among them and related to mobility are the pollution from fossil fuels and congestion and health issues. The number one problem related to mobility is actually the cause of cancer due to emissions and pollutions from fossil fuels. This actually contradicts the zero tolerance rule of having a vision that we should have no deaths in traffic. Congestion problems such as traffic jams creates noise pollution in the soundscape, is also increasing the cost of supporting this infrastructure, and altogether affecting the factors of well-being and building physical limits in our environment with lock-in effects that requires long-term investments and maintenance. An important part of mobility that we see it as today is connected to our freedom and well-being and the ability to move us around and enable us to travel freely. One of these themes that we had in the Challenge Lab this year was mobility. And the starting point for us and our perspective on mobility started out with the Ubigo project that we heard of in one of our dialogue sessions here in the lab with stakeholders that was invited during our first weeks. And the term mobility as a service that came about with Ubigo is a new type of mobility solution that is based on on-demand services. We see them emerging in different fields. It's also about the connected vehicles and the autonomous vehicles that we see emerge now as well, that will transform the society as we know it. These new transport services bring new challenges by having an unpredictable impact on urban mobility. In Scandinavia, has Finland and Sweden been the pioneers and the experimenting grounds for new mobility solutions? And Ubigo was a Vinnova-sponsored project that started as a subscription model with 70 households here in Gothenburg. And what we wanted to find out was why it failed to take off, basically. because they had a good case. They wanted to exploit the high expenses of owning a car with providing incentives to opt out using it. So in theory, you can ask yourself, why should I own a car when it's both smoother and cheaper to buy the need of mobility as a service? So what we did here in the lab was that we formed a thesis pair and combined our study backgrounds, our previous knowledge and interests, and we set out to explore why Ubergo took off. Our main aim can be summarized as the following. As you can see here, how can a combined mobility service platform that benefits all of the involved stakeholders be designed? By using this aim, we try to create some kind of requirements based on information and the concerns that we have for our environment and the demands from our stakeholders, to put that in relation to a central platform and how it could be specified. In order to accomplish this, we created this technical specification as an inspiration for how such a platform could be implemented. We have a very good reason to believe that we as students can interact and retrieve the data that was necessary, but also that we can, due to our neutral position, also investigate how we should travel in the future. The limitations in the report and the distinction of what we looked at is the separation of transportation of goods and people, where our report mainly focused on transportation of people. But we know that the combination of these two are likely to have many synergies, but they are today quite separated. So that's the reason for that. This is the design of our study. During our first 4 weeks here at the lab, as Jon presented to us, we used the criteria for sustainability. Also that we developed that together as students here in the lab, where we defined what mobility means to us. And the stakeholder dialogues that we had here was crucial for us to find our topic and what we wanted to investigate and research in. And the purpose for us is to find a sustainable solution to the complex challenge that mobility is facing. And to do that, we created a very qualitative report. And the consisting parts of it was a literature review. We used interviews, but we also simulated a case that we will show to you later. So what we actually have done is to perform research on 2 separate fields. Blockchain technology, which is a very, very innovative and new technology. Most of you haven't heard about it, possibly, but we'll present that to you. And of course, mobility as a service, both of which are still in its infancy. And most of the sources that we have used in our report is dated from 2014 and onwards. So it's very, very new, and it has been very challenging to find information. And one example of this is we're putting our efforts in the edges of research, and we have an interdisciplinary interaction between different separate fields, and none of them overlaps today, but we will try to present something that can do this. So what we see here is the concept of mobility as a service. What we see as a platform or an ecosystem of mobility services is a definition that actually derived from Helsinki in Finland. And it was first stated and mentioned as a system in which a comprehensive range of mobility services are provided to customers by mobility operators. But what we actually see is that user experience, the mobile phone or the smartphone here, it's only the tip of the iceberg. What actually has enabled mobility as a service today is a high level of connectivity It has been enabled by information technology and information communication technologies and widespread penetration of smartphones. So mobility as a service, it's about integrating multiple mobility services in order to address some of these problems that I mentioned. So examples of these could be to solve urban density problems. You could make getting around more easier. And also owning a car is no longer appealing. For us as a younger generation, we don't see the same need as the older generation. Which also means less congestion, better air quality. So the current framework we have worked around and the challenges that we have investigated is related to users' connection. As I said, enabled by the IT and ICT, that mobility as a service, it requires a very high level of integration, both in the infrastructure, but also at the data, such as travel information, type tables, payments, and other business transaction and agreements. This complex architectural system has a very high variety of solutions and technologies today that unfortunately have a very low interoperability and verticals of silos and proprietary technologies. So the consisting parts that we have been investigating is service providers, the ones that we as users can see the user interface, the customer experience. The platform providers, the companies that are brokering our mobility services and solving the issues with payment and booking. But also we have the mobility providers, the operators that are driving the buses, that are driving the taxis, that takes care of the data and the tickets and perform the activities, operations. So this is a slide that we got from Samtrafiken. As you can see, it's a complex mix of mobility providers that we have in society today. And what Samtrafiken tried to do is to collaborate to create a consortium. And they have a white paper called the Smart Mobility Program that we wanted to include in our presentation. And what it does is that they change the concept of public transport to say that it's now passenger transport with shared resources. So we are facing a paradigm here, obviously. And what these companies all do, or what they have in common, is that most already have or will deploy their own solution. And the question is, how will they integrate? Because most of these companies, they know that they will be disrupted in some way or another. And they also, as maybe I can take your example with fear, they now fear what will happen to them. So what that has created is problems related to how they sell their services. And one thing that is crucial here, that they're quite afraid to sell or let others sell their service. So what Samtrafiken has tried to do is to create or coordinate a system called Res Plus. Maybe some of you have used it before. What Res Plus is, it's the Sweden's largest ticket corporation, where you can buy a ticket on their service and you can use a transport provider here. And the problem is that it's only 3% of the total amount of journeys that are performed in cities today, where most of the trips are purchased as period cards and coupons at the respective public transport authority, such as in Gothenburg we have Västtrafik.
All right, so that was a basic introduction to mobility as a service. So now I'm going to introduce blockchain technology. And to get an understanding of that, what that actually is, we need to take a look at the history and evolution of the internet. So when the internet started, it was basically a place where you could only share ideas because all of the information on the internet was public. So people created forums where they exchanged their interests, and some companies created the websites where they advertised their physical businesses. But then something called HTTPS came about. And what that basically is a form of cryptography which allows you to send information from your computer to a company server without it being public. It's confidential. And that allows us to create an internet of payments, and it's what allows us to like send our credit card information without anyone stealing the information. And being able to pay online has, as you know, completely changed the global trade system, and we now exchange goods from all over the world over the internet. But over the last 20 years, more cryptographic tools have been developed. And the one for payments is just a simple thing. But none of these has really found any applications on the internet. That is until blockchain technology came about. And what blockchain technology allows us to do is basically take all of the physical financial institutions and put them onto the internet. And if you think payments have changed a lot on the internet, payments on the internet has changed a lot, then all of our financial institutions might bring a lot more change in our society. So we go from an internet of payments to an internet of agreements. So to understand more of the structure of how the blockchain works, we're going to take a look at how information is stored within organizations today. So today we have this first picture where all of the organizations store their information separately in databases. And you also have your personal computer where you store your view of the world. And when two organizations want to integrate, their data won't fit together, so they have to have some kind of conversion. And when you want to integrate or interact with 3 different companies, you have to input your personal information 3 times because they all have their different interfaces. One way to approach this problem is to introduce a central authority. And that works in some cases. So examples of this could be like Centralbanken or Lantmäteriet, where their model of the world is the correct one, and everyone has to follow what they're saying. But this might not be ideal in all cases because they might have vested interest and favor some actors rather than being equal to all of them. To your far right, you see what blockchain technology enables. And basically, we have a unified model of reality that we all share. And this is created through a network of computers. And basically, all of the transactions that we do in this network can be verified by everyone. So we have a permanent history that everyone can agree on. But that's only like the database layer. And the other thing we have with blockchain technology is something called a smart contract. And we can also store, in a database you can only store information, but in a blockchain you can store value, such as cryptocurrencies or other digital assets. So a smart contract is a piece of business logic. So if then that, something that happens sequentially and that can allow you to make different agreements. So an example of this is you are a user there with your smartphone. You want a service fulfilled. Create a smart contract. You send it to the network. All participants that are interested in this type of contract, they can listen for it, and they can send a counteroffer when they can provide a service. And the user can accept the contract that it likes the most. And the cool thing about this is that once the user has accepted the contract, it can be quite sure that the service will be fulfilled. And since the contract contains a payment when it's created, the service provider will have a guarantee that once the service is provided, the payment will be released automatically.
Right. So now when we all know what blockchain technology is, we combine that with the framework we used and the the stakeholders we identified as mobility providers here in our study. And as part of the method, the interviews we performed tried to the purpose of the interviews and the questions that we wanted to have answers to was basically our mobility providers' knowledge on mobility as a service and how they define the concept. And what kind of requirements do they have on such a platform? And we also wanted to know if a neutral broker is possible. Is this kind of distributed, decentralized system possible? And of course, then we had to ask about transparency and data sharing. How open are mobility providers today? And this group of people and companies that we interviewed derives from the triple helix, as Jon showed us earlier, but we actually expanded that to something we call a quadruple helix, where we include civil society and non-profit organizations as well. So we performed interviews face-to-face, but also via conference calls, such as Skype. After we performed the interviews, we also introduced what we just saw to our stakeholders, so we could see their reaction and find out what is necessary for blockchain technology to be integrated into mobility as a service. And we saw that there are three major categories that we need to address. And these are the identification system, where we can give examples of if you have a car, or as a company have a car in a carpool or car sharing service, you need to verify, for example, that the driver have a valid driving license. But it could be the other way around as well for users, that they can trust the operators. For example, do you know that the bus is maintained and that the service level is according to the standards? So then we have an agreement platform. Of course, the users need to buy their services, but what actually the platform needs to take care of is if we should have shared journeys, if we have, for example, vehicle renting or paid journeys. For example, the non-profit organizations, due to institutional barriers and legal aspects, they can't make any profits, which is the main reason they exist, but also they can cover the expenses on such an agreement. And the third category that we see is the route planning tool that addresses from where you want to go as a user from A to B, where should a bus stops be placed, for example. And this is both for users and mobility providers, because this spatial information of where the users are traveling, it's necessary to share in order to stimulate a new innovative solution. And in our interviews, we had examples where you as a user maybe want, sometimes if you go to your job or a meeting, you need to have a very fast and smooth journey. But in other cases, maybe you want to have a scenic route, or if you're environmentally conscious, you want to have a low impact on your environment. And what the idea is that we want to enable this kind of multimodality to take place on a platform, on a combined mobility solution. So what we actually saw when we started to look at blockchain technology and mobility as a service is that there's different fields in research and innovation and society that actually is starting to converge. And if you look back in history of how innovation took place, it was a very closed way, where you, as a company or organization, innovated in a very secretive way because you wanted a competitive advantage, that you wanted to have more knowledge than your competitors or your in your market, so to speak. So what is actually happening right now, that there's something that emerges as open innovation. And what that does is that companies now look outwards to find inspiration for new products and services and collaborate. And what this is called, that we refer to our report, it's Open Innovation 1.0, as you can see in the middle of the picture. But the question here, is it inclusive or exclusive? Do the companies want to capture value from the users, or do they want to create new value? And what we see in the field of innovation is that there's something now coming up from the bottom. It's called Open Innovation 2.0. And what it actually do is that it basically have the same structure as blockchain technology on an architectural level. As you can see, it's an ecosystem where all agents can share information with each other, contribute to the best solution. And it removes these and transcends these silos, these vertical solutions that we have today, and it creates a more horizontal environment. And you can see it's like chaos basically, but the role of blockchain here is to bind these together and create trust among them, to share information in a very safe and secure way. And this kind of trust comes from the trust capital that is built into the history and the integrity of the blockchain ledger. And then it's you to present what you can do.
So before Patrick explained the needs we identified from the mobility providers, and we wouldn't know like what of these needs can actually blockchain fulfill. So we think that it can fulfill identification needs and the agreement platform needs, and it cannot fulfill the route planning, since that requires a lot of computation, which is not possible in a blockchain system. But for identification, you could, for example, have, let's say I want to register at 2 carpools, and they both want to know that my driver's license is correct. So I have to verify my driver's license at 2 places, which is kind of annoying. But with a blockchain system, that information can be verified on a blockchain platform, and it only needs to be verified once, and then the information can be owned by the user. And I can say that, yeah, this is already verified. Here you can, when I register at the 2nd carpool, I can hey, it's already verified, check it out. And ideally, this information would be put in a form from Trafikverket as a digital driver's license. And for the agreement platform, you could, there are multiple things that can be fulfilled by the blockchain technology. But as an example, if I want to go from point A to point B, I can create a contract saying that I want to go from point A to point B with this mode of travel. And I put this out to the network, and the mobility providers that can provide a service, they see that, oh, I can do that, and they respond. And I, of course, have already included the payment in the smart contract that I created. And they respond, and the service will be fulfilled, and they will get the payment once I'm at point B. All right. So we also want to know, this central or combined mobility platform, how would that affect the mobility providers that are actually driving and providing services? And we saw basically 2 cases. One case where there was a closed platform, where some mobility providers were allowed in and some were just not allowed into the system. And then an open platform where everyone could plug in to this system. And to explore this, we created an agent-based model, which basically is that users, we create agents that represent the users, and they can choose which mobility provider they want to use given this platform. So this is the result, and here we have 3 columns. The first column, there is no platform. Second column, a closed platform. third column, an open platform. And the interesting thing is that in the middle, we see that some actors are locked out, and that they won't be, even if they have a very innovative service, they won't be able to actually grow that service. And in the platform and no platform, it's quite similar, but the platform provides cheaper transactions and a better user interface for user experience for all the users. In the second row, we explored what happens if we introduce an eco alternative. That is, like we give the users the options to choose an environmentally friendly alternative. And for example, like an electric car, they only want to go buy electric cars. And the open platform actually improved the agent's options to choose the eco option. And the closed platform actually decreased the opportunity for agents to choose the eco option. Right.
Right. So, as you could see, these agents, it's the market we talk about, the platform. It's something. The fundamental principle of this is the market is based on network and network effects, and what agents choose to do is related to what, let's say, their friends are doing. Like if I want to go and travel environmentally friendly and I can see that it's cheaper, I tell that to a friend, I tell that to a friend, and then we have a lot of friends that travels by that mode of transportation. But actually, what this framework is showing, when we analyze the data and the results, as Joel said, there are two possible paths for mobility as a service to take in the future, and this is a question about centralization or decentralization. And the dimensions here that we see today is that we are in a closed state and we are now moving towards an open state. And the framework here that we used and the ideas are according to Gsm Model. And the networks effects that we talk about is also that the platform, it's about standardization, that we can perform some kind of service and we can agree to do that in a standard way. And what we see now is that there's a competition going on about this dominant design, that Ubigo, for example, is trying to create one service. In Finland, they do one service, and they compete about how good it actually is. And it creates mutual benefits, of course. But once the dominant design is in place, the network effects, instead of competing of the dominant solution or the platform, it's rather about price and innovation and differentiation in the market. And what that relates to is the switching cost for a user. For example, if you want to switch from one platform to another, we can take Uber, for example. You have your Uber app, you have your Uber account, you put in your credit card, but can you use that on Västtrafik and the bus? The switching cost is very high today. And what we see potentially is that we have a GSM model, it's called. It relates to the telecom business, how it was deregulated, and we now have, for example, we have different mobile operators on the market. And what they have done, or what we see, is that we see some potential that we have a license to operate. For example, Ubigo can get one part of the market and operate in that, and you have another solution and they operate in their way. But as we have it today, the market is, as you can see in the bottom right quadrant, is that we have a very fragmented model where different solutions compete. And what this actually creates is that it's a high competitive environment and it's a very low efficiency and a very low resource efficiency. So the paradox in this environment that we have here today is a paradox, because we have platform sponsors like Samtrafik, and they now build alliances and they use these kind of strategies that we see on network markets, and they're exploiting the first mover advantage of being the first to deliver their solution. But what they need to do, and what they do now, is to managing the customer's expectations. Maybe you got some expectations from our presentation, for example. But what we would like to see and what actually blockchain can enable is that if you see the internet model in the right upper quadrant, we can create a very fair and reasonable and non-discriminatory terms on that market for everyone to compete and come together, enabled by smart contracts. And the concept of this can actually be programmed in logic on smart contracts, reducing all the negative impacts that potentially companies that want to exploit this. Because in the GSM model, these platform owners, they can maybe collude, and you have then issues with antitrust, and they can increase the cost on the platform for users to use it, and we see different problems with this kind of solution. It also applies transaction cost to it from the very first start, because they need to maybe have a license to operate, and they need to pay that license, and they need to build their own platform. They need to support that and maintain that with investments and so on. So the next level is actually what we talked about earlier with blockchain, is the Internet of Agreements, where you have no intermediaries and peer-to-peer business, as the internet model depicts. And the conclusion, to sum it up then, is that we see that blockchain technology is a very, very good fit with mobility as a service, where you can take business to customer transactions, and in the future also make machine to customer transactions or machine to machine transactions in case of autonomous vehicles. It, for example, can negotiate the car itself. As one question came up in the interviews, what happens when the car owns itself, for example? It can negotiate insurances. It can make service agreements and actually control the status of the car autonomously. And what we also want to present is the importance of having a neutral platform, because what this actually enables is, if we want to travel with shared resources, we need to consider accessibility over ownership, together with increased awareness of sustainability and resource efficiency. That is the driving factors behind this transition that we see today. And the levels of which the blockchain technology can integrate into mobility as a service is basically not seen in other solutions, because it's a distributed solution that is not only secure, but also ensures independence to all the mobility providers, and de facto solves a lot of the issues. And what this requires is a public blockchain. And the GSM model, for example, it could be a consortium blockchain solution, and it creates this kind of switch costs, where it's hard to transition from one service to another. And our conclusion is that the next generation of mobility as a service ecosystems should be built on an open and decentralized blockchain that is actually diminishing the transaction costs, because we use a shared platform that we all can agree on how it operates and how it works. And that is basically the end of our presentation. Thank you.
Thank you, Joel and Patrick. And this is not the end, because in master thesis presentations there is also an opposition, and where the students, your friends, will ask initiated questions regarding your master thesis presentation and your whole master thesis. So, Barkin and Johannes.
Shall we move over there, or can we address our question?
I think everyone can hear you,
Yeah, sure.
and this microphone here is really sensitive. So, but if you want to come on stage, then everyone can see you. So it's nicer.
All right.
Yeah.
Thank you for the presentation and your work. Thank you for sharing with us. I mean, with the presentation structure, I like the depictions that you created, the illustrations. They were quite explanatory. However, the presentation was a bit too long. I mean, it even ate up from our. Um, anyways, let's go to the questions. So you mentioned timetables. Maybe you should.
Yeah, I also have a few summaries
yeah.
before. So thank you for the presentation. Anyways, it was very good, and thank you for having us to read the thesis. I really liked your structure and your way of presenting. Even for me, who doesn't know a lot about ICT or business, I was really able to understand what the topic is about. So you gave a really good background about ongoing and past projects. That was really nice. And I really liked the new method that you even sometimes are self-critical to what you write. So that was really good to see that at some points you even don't take everything you do for granted. That's good to see. Then coming to the questions, my first and foremost question was maybe during your research, what would you say was the most surprising information that you gathered in it? What was the new things that you didn't expect when starting it?
Yeah, that was something that came up during the interviews. I think most of us are familiar with something that we called Gsm Model or the Gsm spirit. And what it actually means is that these kind of alliances or consortium that we see on the market of mobility today, they are very exclusive and not inclusive at all. So that was the most kind of surprising thing that we actually have data on. Yes.
Yeah, I mean, I have some questions about your proposed structure. Yeah, this is here I go. How do we break the resistance against sharing? Because we know that there's quite a strong resistance against sharing economy, especially when it comes to mobility. People don't want to give up their choices. There are several studies about it. So who do we target with this proposal, with this mass blockchain proposal? What is your target group?
I mean, I think it's hard to right now decide on a specific target, but I think what is needed in order for something like this, an open system, to evolve, we need to have examples so that people can see, oh, this is actually very open and it works really well. And once that starts having networks effect, it will be very fast to take off.
Okay.
Maybe another question, like hypothetically speaking, in the very far future, if this takes off, for me, I kind of see maybe public transportation nowadays as some kind of mobility as a service on a very centralized way done and very limited and very not very flexible. So that's some of the points, and that's why a lot of people don't use public transportation at the end. But in case this takes off and it is successful, do you think, and what we see with Uber, do you think it could actually a mobility as a service on a shared platform, do you think it could replace something centrally organized such as public transportation?
Potentially, yes. Because if we think of the analysis framework that we showed, the monopoly model that we have today with the public transport operating as one single entity, enjoying that position. What we do if we open up the market, we need the technology today are already disrupting the public transport. But if we deregulate the public transport, potentially the technological solutions can be one way forward to solve the issues.
But I also think that the way public transport is structured now, it is very cheap since it's subsidized, and I think the structure it has is very rigid, and I think, I mean, maybe not in the far future, but in the foreseeable future, it will be there, but it will be complemented by a lot of other services.
Yeah. So that could be a potential area for further research to see what's happened when we have a higher degree of resource efficiency, and we can distribute the costs of those resources more evenly. Because today we only have one vertical where we subsidize everything, but no one else take part of that. And we have a lot of cars, and if we share cars, we can, share the costs.
Yeah, and potentially, this kind of technology could potentially allow governments to subsidize, this service is really nice and it's aligned with our vision of what is good. So then maybe they can subsidize more dynamically.
Well, I had a couple of questions about public transport. I'm coming from transportation background, so I'm kind of conservative in that sense. But I won't address them, as your thesis is mostly about blockchain. So I have a question about blockchain. How do we know after we've moved to this decentralized system that it won't fail? I mean, how do we make sure that it will stay effective after we've moved all our sources to that?
So, I mean, all systems can fail.
Yeah.
Of course. And if we look at this kind of system compared to the systems we have today, this system is open source, which means that everyone can look and have an understanding, or if you have the technical knowledge, you can see that how it works and verify it. The systems that we use today are proprietary mostly, both in the financial sector, but also in mobility sector as well. And there you can't have the same kind of verification. And if that system fails, you need some specific company to come in and fix that. And I think that having a more open system will get us more security in that sense.
Okay, I think I have tons of questions, but then we can discuss in a lot longer sessions. But at this point, these were the most pressing ones. Thank you again for the presentation of the thesis.
Yeah, thanks for your questions.
And thank you for the questions. So now it is time for you to pose questions regarding this exciting master thesis and the new technology that's now been introduced.
I didn't understand the simulations. What was the X and Y axis?
So sorry for rushing through that. But the y-axis was how many.
Can you show it?
Oh yeah, sure. Yeah, we can go back. So the y-axis is the number of agents that are using a particular mobility provider, and the x-axis is time. So basically, they start at very low usage, and then some networks effects take place, and some mobility providers get more users.
Was that a clarification?
Can I ask a question? I just recently used a service on the internet where you could sort of ask for a car reparation from several providers. You put out what you were wanting, and then you were supposed to get sort of an offer from them. But that demands that the providers that actually they see it, they calculate, they think about it, and then they answer. And it didn't happen. The blockchain technique is that coming with some sort of automatic for the providers, service providers, because they can't deal with the information out there in the network. It has to be automated in some way.
Yeah, so the blockchain itself doesn't come with some sort of automation in that sense, but it's easier to provide those kind of optimization services since you have like a single interface. And the service you used was probably closed, and there was some company that was in charge of it, and then there is not the same drive to create tools for different organizations.
Yeah. So what you described for us is something we call it's a network market, or a market that consists of a network. Okay, but there's something called two-sided networks that we present in the report, and what that means is that as a user on one side, creating a supply or a demand for services, and then you have the other side of the network that creating the supply side. And what that platform, the website you visited, have failed to do is to attract or create incentives for the supply side to make use of your information. That could possibly be of, it could depend on that the supply chain, the supply side platform sponsor failed to have the right incentives for different companies to come in and provide their services. There's a good example of this to make it more clear is to take Facebook as an example. You have a lot of users, we have a lot of people creating their own accounts, and on the other side you have advertisers that pay to generate leads on their sales, on their own websites. They can pay to advertise and have that. And the mediator in the middle is Facebook. And what you describe is something similar to Facebook. But they failed at one point. So what can happen if that platform tells the companies that, look here, we have a lot of people that need help with their cars. They have a lot of demand that will attract new companies to get into the supply side and provide their solutions.
Given that blockchain requires a lot of computer power infrastructure, who do you think should own that? Should it be like public government or private owned? Because that would be really important if anyone actually going to succeed.
Yeah.
Infrastructure is there is open.
So there's currently two kind of models that are being developed. One is the public blockchain, like Bitcoin and Ethereum, and one is more private or consortium blockchains. An example of this is Hyperledger. I think the thing we think by exploring this is that we really want the public blockchain because that is open for everyone to participate. And the private blockchain is it's controlled by an entity and or a collection of entities. And these, if it's like 3 companies or 2 governments and a company, then they have the authority to change the history of what has happened. And we think that that is a bad thing. And we should really be have a public blockchain where the history is enforced by the economic incentives in the system. And thereby there's no one like authority that can change the history.
Gentlemen?
Yeah, I just wanted to ask if you know of any like real world projects that they're actually trying to build what you
There's different examples, but it's the level of integration is different. What we talk about is like the complete full package of integration. But for example, in Germany, there's a company working together with BMW that integrated Bitcoin as a payment solution for using that in a car sharing solution. But there's also other organizations that has tried to actually disrupt Uber itself. For example, in Austin, Texas.
Yeah, they basically try to. It's called Swarm now, and it basically tries to create a decentralized Uber. But what we think is possible is not only like have a decentralized Uber, but having a platform where we can integrate all of the existing mobility providers as well. And we haven't found anyone that's working on that.
Are you going to try to do that?
I mean, it would be an interesting code.
Yeah.
I can imagine that one reason why I have a centralized system for public transportation is to still have routes for very low density areas in the region to have subsidized, we going in a full bus, pay for those going half full bus. But maybe this system will make the system smarter and take care of that and send a smaller bus to that area. Or what do you think about that kind of transaction within the system? And will this be a tool for that, or will it be difficulties related to this aspect?
One thing that we write in our report is that potentially one cause of why we have a subsidized public transport today is because it's a very low efficiency rate of that. Like we have buses going around in very rural places that are empty. And if you have a platform, you can have maybe free-floating public transport in the future. Who knows? We don't know which kind of solution or business model that will grow in the ecosystem. But of course, it could be smarter if we use one platform instead of having separate vertical solutions for every company.
Just a point. But the risk when you set it free is that the market will concentrate on where you can earn money.
But it's not like we can't have subsidized travels. Like I mentioned in another question, like maybe we can subsidize, like the government can see like, oh, this type of journey is happening here, and it should happen more. Then they can subsidize that journey more easily. So I think this will not like remove subsidies, but it can make them more efficient and point them to where they really are needed.
It's actually related to the transactions costs today, because we put a lot of money into supporting different vertical solutions. If we can pull up those assets and distribute them evenly instead, then we have a totally different case, I think.
I was thinking recently asked for reactions to that. What were the reactions?
So we introduced the concept of blockchain and like asked how could this fit into your business model like that. But since the concept is so new, it was hard for them to actually put this into the context of their businesses. And they saw that this might actually change something for us, but they couldn't really actually put it into like a concept.
Follow up on that is that when we interviewed different actors, like large actors or small actors or stakeholders, we saw that the way they could adopt the technology is of course different. For example, the larger organizations that we interviewed, they are very slow to adapt and very resistant to change. They try to build solutions, but they are very, very slow on that. But smaller companies, they are much, much faster in that sense. So related to that, also that the reaction we got when we present blockchain, especially, was kind of the reaction that this is the future. The only question is with which path should we go?
Yeah, just following on to that, what do you see as the main hurdles this could be an aspect for? Both in terms of the big guys that may just don't want to climb out of the closed system, as well as the everyday person. Because it sounds like you have to be quite technology savvy with your own impact on that stuff. But what do you see needs to happen in order to from that point?
So I think one like major hurdle is that I think this technology needs to be integrated not only in mobility as a service, but in other aspects of or other services in society as well. And it can't just, I think it's hard for it to happen in only one sector, and it needs to be integrated in a lot of different sectors simultaneously, maybe. But I think that could be one of the major hurdles.
You started your presentation being quite concerned about the environmental aspects and also health aspects, but then during the presentation you talk more about freedom and low costs and so forth. So I'm just wondering, what do you think are the main driving forces for this kind of technology?
Well, we look on sharing economy as a trend in our report, and what that does to people, how we now start to collaborate on different things. We share resources in another degree that we are used to. And what that creates is it enables well-being, and also the higher resource efficiency that we create also enables us to put time and money and effort in other things, actually. So that is related to that.
But I think also that this kind of systems could or will probably provide us with more information, and with more information we can make more informed decisions on these kind of topics.
Yeah. And the information is crucial here. Like with the smart contract, for example, we can incentivize to remove negative rebound effects or negative externalities on a platform. So it can be kind of self-controlled in that sense, where people that misbehave or operators that misbehave use fossil fuels, for example. We can create incentives because the agents, the users in the platform will select other alternatives because it's more beneficial in that. As the simulation shows, we have tried to create an environment and see what happens. But in real world scenario, it's very highly dependent on that adoption rate on the supply chain side, but also on the innovation that takes place.
Yeah, and as you said in the simulation actually showed that in the open platform system, users have greater ability to choose the environmental friendly options, and in the closed system, their ability to do so was lower.
All right, the two final questions.
So do you think that governments will provide like a blockchain ID, or do I as a user have to some sort of verify my identity somehow?
So yes and no. So if you look at Estonia, for example, they are providing a digital identity. It's not a blockchain identity yet. It can be used to interact with blockchains, and I think the Estonian government is looking at that, but it's not natively yet. But I think we are moving in that direction. But also, this kind of technology enables us to have self-sovereign identity, which you control, and that is not issued by the government.
Johannes, you had a question.
Maybe back to the users and what they choose. So in that sense, do you think with the platform real-time, can potentially users also willingly choose unsustainable solutions? So is the move towards a more eco-friendly, is that user-driven, or can you also have a technology-driven way of supporting these solutions? I don't know, maybe I want to drive a big ass truck that has a large exhaust.
I think it's hard to technologically stop that kind of behavior. That's something you have to. I mean, the way that is approached is by subsidies or the regulation by governments. So I don't think like the technology natively will make users see that perspective, but it could certainly help people wanting to promote that perspective and like a more sustainable perspective do that.
I think related to the question, if I just think of what MIT presented last week, for example, with the Toyota, where you have the car connected to the blockchain, and actually the car itself pays these road tolls and potentially tax and environmental costs. And if you put the information of that someone is using that car that is very environmentally unfriendly, then potentially someone can pinpoint that in some way. I don't know, but you can potentially create a solution for that. I don't know how it will work out, but yeah.
All right. I have one question also. It's regarding the footprint of the computational capacity to uphold the distributed ledger. Currently, internet uses about 2% of the gives rise to 2% of the global emissions. And I'm thinking that if like an autonomous car, for instance, generates 2 terabytes of data per day, and with all that data had to be distributed onto all the so-called or the miners of this whatever currency you want to use, or transporterium, or what you want to call it. But what type of energy requirements would it be to uphold such a platform?
So basically, there's a distinction between the mining, which is very energy. What do you say? It requires a lot of energy. Yeah. And the storing of data. Because storing of data, we have systems for the outside of the blockchain system itself, and you can link that data into the blockchain system. But there's also efforts looking at how can we make this blockchain system not use this really energy-consuming consensus algorithms, and have something that's more like energy efficient. And that is some systems use them and some don't. And the problem with them is that they might not be as secure, but it's a trade-off. And I think the way we solve some of these problems is to create more efficient sources of energy.
I think it's also related to Moore's law, like technology itself that do perform the computations. The performance are increasing exponentially. So the amount of energy we use today to calculate this, like in 2 years, it will be a lot less. So that is also something that we need to consider.
Right. Thank you very much. And remember where you heard these things first. Now we take 10 minutes. Sorry. And now we take an intense 10-minute break, meaning 7 minutes. And there's a speaker over there.